For this video, let's try to prove the last trigonometric function together with its derivative. We have here the derivative of cosecant z is equivalent to the negative of cosecant z and cotangent z. This is actually the same as the rule or the identity for the derivative of our cosecant function in terms of real numbers. We have here again our function. Identified as cosecant of z. Now, we will be using here the rule on differentiating quotient of function rather. Yes, quotient, because our function can be written as 1 over sine z. And it's a function, this will be our denominator, that's our numerator. Here, let's not use the definition because it will take us a lot of time. We will have here, say for example, our k of x is the ratio of m of x and n of x. The first derivative of k of x is the composition of your denominator times the derivative of your numerator minus your numerator times the derivative of your denominator over the square of whatever function you can see in your denominator. So basically, our given here being cosecant z, its equivalent is 1 over sine z. The denominator is a function, sine z, while the numerator is a constant 1. So its first derivative is this, the denominator. Derivative of 1, your numerator is 0, minus your numerator 1, and then what is the derivative of sine z? This is already proven to be cosine of z. So times cosine of z all over the square of your sine z. This is actually 0 minus cosine of z over the square of sine of z. Let me stick to that square first. As I move down, this would be equivalent to negative of cosine z over the square of sine z. The square of cosine z means there are two sine z's in our denominator. Okay, so you have here sine z times sine z. Now, take note that if we have expressions like this, let's say 12 over 16, you know it's equivalent form, right? But this is actually equivalent to, let's say, 3 times 4 times 4 times 4. Or you can break that into two different fractions, 3 over 4 times 4 over 4. Similar here, if we're going to pair this with that, and pair it with the remaining concept in numerator, take note we have 1 here, and allow me to factor out negative, leaving here 1 over sine z for the first, and the second one is cosine z over sine z. It's still correct identity. This would mean this is equivalent to negative 1 over sine z. We know that to be cosecant of z, and cosine z over sine z is equivalent to cotangent of z. This is now the intended target. This shows that the derivative of cosecant z is equivalent to negative of cosecant z times cotangent z, which is also true for the identity in real numbers. This is the proof for this, and if you see later on this type of function, you can of course use this equivalent now. Thank you very much for watching.